Welcome to IB Chemistry exam preparation, exam tips for both standard level and higher level. Today, through our lesson, I'm going to focus on topic number 6, which is kinetic rate of chemical reactions for standard level. Through our lesson, we will learn and discuss how can we determine the rate of chemical reactions taken from the graph. In order to start with calculating or finding the rate of the graph, the first thing is to learn together what are the two shapes of graphs that can be presented whenever we are talking about rate of chemical reaction. So let's get started. Here I have the two different graphs that can be taken whenever we are considering the rate of reaction. So, if we are following a reactant's property per unit of time, I'm going to find that I have a y and the x-axis. So here I have the property of the reactant, no matter what is this property. It could be concentration, it could be mass, it could be pH, could be conductivity. So I'm going to write on the y-axis right here the property that we are measuring. When considering the property that we can measure within time, you need to go back to our kinetic part 1 video. We discussed in details what are the different properties that you can measure per unit of time. So if you've got a reactant and you are following the reactant's concentration or property per unit of time, you need to remember that this property, no matter what is this property is, it will decrease per unit of time, then it will become constant. When the graph or the curve that you have becomes constant, so this is the time at which the reaction reaches completion. So here the reaction ended. Because of that, you're going to find that the shape of the graph, it becomes at the end flat. The reactant's concentration per unit time decreases, so it will start at a very high concentration or property, and within time it will start to decrease. On the other side, if you are following up a property for a product, another time this property could be anything. So on the y, I have the property, and on the x, I have the time. The property will start from the 0 as we are considering products, and it will start to increase. Then at the end of the reaction, it will become constant. So when the curve becomes flat, this is an indication that the chemical reaction is ended. So these are the two different shapes of graphs that can be used in order to determine the rate of reaction. I've got here a figure that presents joining both graphs together. So in the red color, I have the products that starts from 0, then it increases per unit of time. And on the blue color curve, I have the reactants that decreases per unit of time. If you look at the two curves, you're going to find that both of them, they become constant or flat at the same time. So this is an indication that this is the time at which the reaction reaches completion and it has been completed. Because of that, the concentration or the property which we are using or measuring per unit of time becomes constant. Now let's consider how can we determine the rate of reaction from these graphs. In most cases, the rate of reaction decreases within time. This is because the concentration of reactants decreases per unit of time. And at the end, the chemical reaction always depends on the reactant concentration. We're going to prove how the rate of reaction decreases per unit of time, taking into consideration different types of rates. We're going to measure it within the graphs that we have. So let's start. The rate of reaction can be classified into three types. We have what's called by average rate of reaction. The second is named as instantaneous rate of reaction. When talking about instantaneous, it's the rate of reaction at a specific time during the reaction. So it's not the average. It is the rate at a specific time. Now, number 3, we have the initial rate of reaction, which is the rate of reaction at time which equals to 0. Through our lesson for today, we're going to be able to measure and to calculate and to determine these three main types of rates: average, instantaneous at a specific time given. Finally, I have the initial rate of reaction. We will start firstly with calculating the average rate of reaction. So if you look at this graph, you're going to find that on the y-axis, I am following the volume of hydrogen gas in cubic centimeter, which is collected per unit of time in seconds. So if I want to calculate the average rate of reaction, I'm going to take the maximum volume of gas that is collected, and this can be taken directly from my reading on my y-axis. So the maximum volume of hydrogen gas that has been collected, it is approximately 67, could be also 68. So it is according to the number that you have on the graph. I wrote it down as being 67. So you need to take the y as being the volume of gas that has been collected. Volume of H2 gas as a total volume taken from the graph. After that, you're going to divide over the time at which the reaction is completed. So it's the time at which the graph becomes flat. So if you read this time, you're going to find that according to my graph, it took 36 seconds exactly in order to finish. So remember, you're going to take the volume of hydrogen gas and you're going to divide it over the time taken to end the reaction. To end the reaction. If you divide the total volume of gas or property collected over the time, you're going to obtain what's called by the average rate of reaction. So in my situation here, according to the graph given, it will be 67 divided over 36 seconds. So your final answer using the calculator is 1.86. If you want to write it into a correct number of significant figures, so it will be 1.9. Talking about the unit now, since you are measuring volume and the time is seconds, so the final unit, it would be cubic centimeter over second. This is how you can determine the average rate of reaction. Now we're going to go into the second type of rate of reactions, which is calculating the instantaneous rate of reaction. Here we need to remember that the instantaneous rate of reaction, it's the rate at a specific time given. Rate at a specific time given. So inside the question, they will tell you exactly at which time do you want to calculate the rate of this chemical reaction. In order to determine the instantaneous rate, we have some steps which are given at the bottom. What would be the first step through your calculation? Number 1, you need to draw a tangent on the time at which you want to calculate the rate of reaction at. After that, number 2, you will calculate the slope of this tangent, which is delta y change over delta x. Finally, the slope of this tangent equals the rate of reaction. These are the steps that we're going to perform. Remember that through your external, if they ask you to describe how can you determine the instantaneous rate of reaction, these are the 3 different points that should be mentioned inside your answer. Drawing the tangent at a specific time, calculating the slope of this tangent or the gradient, and finally this tangent, it will equal to the rate of reaction. Let's go above into the graph and look at the tangent. Inside this graph, as you can see, we have the time, which is t1. We want to determine the instantaneous rate at this time. So, on my curve, I'm going using a ruler to draw a tangent. Remember that the tangent, it only passes through one point, which is the time at which I want to calculate the rate at. So using a ruler, you will be able to draw your tangent. After that, you will calculate the slope of this tangent. Whenever you want to calculate the slope, so you will take 2 numbers and you're going to take delta y over delta x. So you can, for example, take this number right here and another number right here, then to determine the slope of this tangent, which will equal to your rate. Here I have a very important note as a study tip that will help you when applying on calculations. When you want to calculate the slope, take 2 points which are far away from each other. Don't take them close. So try as possible to take them far away. This way, your rate answer will be within the range given in the mark scheme. Now we're going to apply. Inside the past paper, when they want to ask you about determining the instantaneous rate, the final answer is given within a range. So if you are within this range, you're going to take a correct and accepted answer. In order to make sure that you have more accurate calculations, take the 2 points far as possible from each other. Now we're going to continue with the last type of rate, which is considered the initial rate of reaction. The initial rate of reaction is very similar to instantaneous, since we're going to calculate the rate at a specific time, which is the time that is equal to the 0. So what are the steps that we're going to use for calculating our initial rate? Number 1, you're going to draw a tangent, but this time the tangent, it would be at a time of 0. After that, you're going to calculate the slope of the tangent by taking delta y over delta x. Finally, you're going to have the slope of this tangent as being the initial rate. So let's look at the graph. So if I want to determine inside this example my initial rate, it is so important for me to draw a tangent. If you look at the tangent drawn, you're going to find that it is exactly from the 0 and it passes through t equals 0. Here, let's read this note. When drawing the tangent at a time equals 0, it should be close to the curve, not the y. So whenever you want to draw your tangent, make sure that your line drawn, it is close as possible to your curve in order to be within the accepted range when you want to calculate. After that, you will be calculating the rate, which will equal to the slope. So here they took the 0, 0 as a first point in the answer. And they took another number, which is actually right here. And this was given as approximate 2 and 20. So this is 20 as an x-axis, and this is my 2. So when you want to calculate the delta y over delta x, as given inside the question, you're going to take 2 minus 0 for the y over 20 minus 0, and your final answer, it is considered as 0.1. Looking at the unit given for the final answer, since the concentration is in mole per liter or decimeter cube, so it will be mole over liter and second. You can, of course, rewrite this unit as mole decimeter to the power of -3 and second to the power of -1. Since the property that we are measuring on the y-axis, it is the concentration. Now we're going to go through and apply from the past paper. So inside this question, we have a bromine and methanoic acid react in aqueous solution. So I have here a balanced chemical reaction for a bromine with methanoic acid. There is a production of carbon dioxide as a gas. The reaction was monitored by measuring the volume of carbon dioxide produced as time progressed. Here we use as equipment or tool to collect the carbon dioxide the gas syringe, and we discussed the use of gas syringe in kinetic part 1 of lessons. So you can go back another time and you can look for how can we use this gas syringe as one of the experimental method to monitor the rate of chemical reaction, since there is a gas produced from this reaction. We have here the graph that shows the volume of carbon dioxide and the time. So if I'm going now to look at my graph, I can maybe start thinking about the average rate. So if I want to ask about the average rate, we need here to remember that to calculate the average rate, we're going to take the maximum property collected, which is in my situation, volume of carbon dioxide, which is exactly at a 25. So this is my maximum volume. So I'm going to read this volume, which is considered the maximum volume collected. So it will be 25 divided over the time at which the reaction is completed. You're going to find that the reaction reaches completion at 100 seconds. So your final answer here, it is 0.25, and the unit is cubic centimeter over second. So this is in case of calculating the average rate of reaction. Now we will go through the question. What's the question asking about according to past paper? The first part, which is A, the question is asking me to determine from the graph the rate of reaction at 20 seconds. In this situation, it's asking me to determine the instantaneous rate of reaction. So they specify for me the time and showing your work, and there is here 3 marks. So if the question is asking to show your work, definitely there is a mark on drawing your tangent. So let's go back to the graph. So the question now is asking me to determine the instantaneous rate. Here I need to remember that the instantaneous rate, in order to determine it, I need to draw a tangent. Make sure to use a ruler. So this is my tangent that will pass exactly by 1 point, which is, according to the question here, it is 20 seconds. Now, after calculating or drawing the tangent, you need to take 2 points and you need to read what are the values, and then you need to determine the rate of chemical reaction. So according to my tangent, I can be taking 2 numbers. The first number here, it is 40 and it is a 25. So this is my first number. The second one, I will take it as possible far from my first mark. So this one would be Here the scale, it is 20. So this is 5, 10, 15, 20. I'm going to start reading by how many numbers they are considered here. And here I have the number as being 10. So I will be measuring this. Okay, the middle part of my 20 here, it is right here exactly, which is considered as being 10. So in this situation, I will take my readings and take the two values considered here. So I will find now the scale proper. 1, 2, 3, 4, 5. So it's 20 divided over 5. So I actually got 4 each time. So I'm going now to erase this. And I'm going to write down the number. So I have here 4. This is my number. And the second one on my y-axis, it's a 10. So this is my value here. Whenever you want to read, make sure that you properly find the smallest scale. In my situation here, I took the 20 and I divide over how many times is presented inside my scale, how many lines. So it's a 5. So it's a 20 divided over 5. So I find that the difference is considered as 4. This is the easiest way whenever you want to read the scale presented inside the graph. So now after having the tangent and having 2 points, you're going to calculate the slope, which is delta y over delta x. So this would be my x1, this is my y1, this is my x2, and this is my y2. So it will be 25 minus 10 divided over 40 minus 4. And you will be using your calculator to find out the final answer. I will go back now to the mark scheme. The question is out of 3 marks. Where are the 3 marks in order to be able and take them? Number 1, you need to show your tangent, which is drawn exactly at a 22nd. After that, you need to make sure that the slope or gradient calculation is also shown. And finally, your final answer, which is in this situation 0.35. If you look at the mark scheme, they usually give a range. So if you are within this accepted range, so you will take the final answer. Now for the unit, it's not apart from the answer. It is presented between 2 different crosses or quotations, which is an indication that they are not apart from your mark. This is how you can take the 3 marks. Now, going through B, outline with a reason another property that could be monitored to measure the rate of this reaction. We have many different methods that can be used to measure and to monitor the rate of reaction, and we already discussed this before in Kinetics section part number 1 from the first video. So yes, you can go back another time. So I have here 2 alternative methods. Number 1, I can use a colorimeter, which is the change in color per unit of time, since we have a bromine and changes its color. It is from reddish brown, or let's say it's more than orange, to become colorless. The second, I can follow the conductivity. Here we have a greater increase in the ions inside the products. So if we go back into the balanced chemical equation, so you're going to find that we have ions. So I can use the conductivity. I can use also the color change since you have a bromine. We can also use the pH. You can also measure or follow or monitor the rate by the change in pH, since we have hydrogen ions production. So definitely the pH in this situation, it will increase. The hydrogen positive will increase, but the pH value, it will decrease. You cannot go through the volume since this is the method used. So these are 2 possible answers, and there are others. Now, it is so important also whenever we want to apply on the graphs to be familiar on calculating the instantaneous, calculating the initial, and calculating the average for the second shape possible inside your kinetic. This is the second possible graph. So if you look at this graph, I need to make sure that you know how to draw the tangents, and I'm sure that you took this inside math. So if you want to calculate or to determine the instantaneous, another time you need to have the tangent, which should be drawn exactly from the time equal 0. So this is my tangent. I'm trying to label it another time. And if you want to draw the instantaneous at a specific time, let's say it is 600, so you're going to draw your tangent in this way. So this is my tangent. So make sure that you know how to draw the tangents for both graphs, either increasing or decreasing per unit of time according to the property. And in the same situation, of course, in this situation, you need to follow up the change as the gradient of the tangent. The last thing that we're going to learn for today is explaining the shape of the graph and referring to the shape as the slope of the tangent. We learned through our lesson that the rate is directly taken by the graph through calculating the slope or the gradient of the tangent. So, if we want to start here, explaining the graph. Whenever we want to explain the graph, we need to remember that the graph, it would be divided into 3 main parts. I'm going to specify it here as A. This is part A. I have part B, which is within time. And I have finally, which is the C, the end of the reaction. So considering A part from the graph, which is number 1. This one is the initial rate of reaction. So if you want to take the slope of the tangent at time equals 0, you're going to find that the slope, it would be the highest. The curve drawn, it is the steepest. So what can we explain or describe the shape? We're going to say the initial rate of reaction is the fastest. Of course, at the beginning of any reaction, the reaction is as the fastest rate. And this can be proved by the calculations. The slope of the tangent at time equals 0, it will be the highest. When we want to explain why, this is because the concentration of reaction is in maximum. So at the beginning of the reaction, when you're going to add the reactants together, of course, the concentration of reactants, they are at max. So we have the highest frequency of collisions. We will talk about the collision theory later. So this will cause to have definitely the fastest rate of reaction. So this is for stage A. Continuing with stage B, which is the second part of my graph, you're going to find that if I want to draw a tangent at any specific time, we're going to find that the tangent in this situation, it will become less steep. So what happens to the rate within time? It of course decreases. So the reaction becomes slower. And if we want to explain why, we need to refer to the concentration of reactants. Since the chemical reaction started, so due to the concentration decrease, the reactants are being consumed per unit of time, so definitely the rate of reaction will decrease. Finally, we have stage number C. If we want to look for stage C, we're going to find that the reaction becomes as a curve flat. It becomes actually as a slope equals 0 here. So at the end of the reaction will equal to 0. So there is no rate at all. The reaction is ended because the reactants are totally been consumed during the reaction. So for any graph taken inside the kinetic chapter, you need to remember that the rate of reaction decreases. We start with the highest possible rate of reaction, and the slope of the tangent drawn initially, it will be the highest. Per unit of time, the rate of reaction will decrease until reaching the end of the reaction, into which the concentration or the reactants have been totally consumed, so the reaction it is done. This is our lesson for today. I hope to see you later in another lesson. We're going to continue with the collision theory, and we're going to learn the factors that affects the rate of chemical reaction. Thank you for watching.